So welcome everybody to this latest video on 162 Maths, and in this video we'll be going through simplifying algebraic fractions with calculations. So in examples of this is when you're adding and subtracting, multiplying, dividing with algebraic fractions. Now we'll go through the general processes and some top tips before going through some past exam questions that you're going to be accustomed to experiencing at GCSE level. Now, before we get started, it's really important that we go over the general concepts of doing calculations with numerical fractions, because this approach is exactly the same to how you should approach algebraic fractions. So just as a quick refresh, if we look at adding and subtracting, so here your main objective is to try and get the denominators the same, and then you either add or subtract the denominators and the denominator stays the same. So for example, if I had 2 over 3 plus 1 over 4, so here I want to try to find a common denominator, so I rewrite both those. A common multiple of 3 and 4 is 12, and then I've multiplied the first fraction by 4, so that's going to be 8, and I've multiplied the second fraction by 3, so that's going to be 3. Then that's then going to be 8 plus 3 over 12, which gives me 11 over 12, and there is my final answer. Now, if it was subtraction, it'd be exactly the same. So let me just delete the plus. That's going to be a minus. This will be a subtraction. That'll be a subtraction, and it will actually be 8 take away 3, which is 5, and that can't be simplified. Then with multiplying, again, all you want to do here is multiply the numerators and then multiply the denominators. So again, if I had 2/3 times, let's go for 3 over 5, then that's going to be 2 times 3 over 3 times 5, which is 6 over 15, and we can simplify that by dividing both the top and the bottom by 3, so it becomes 2 over 5, and there is my final answer. And then we're dividing. The general rule is we flip the second fraction, replace the division symbol with a multiply, and then we multiply. So again, if I had, for this one, let's say I had 2/3 divided by I don't know, 3/8, then the first fraction stays the same. We flip the second fraction, so that becomes 8 over 3, and we replace the division symbol with the multiply, and then we just do the multiplication. So it's 2 times 8 over 3 times 3, so that's 16 over 9, and we can either leave it as an improper fraction or you can write it as a mixed number, so that's going to be 1 and 7/9, and there is my final answer. Now remember that when you are working with fractions, that remember to simplify where possible, either before or after. Your answer should always be your simplified answer, so whether you've simplified at the start before following these steps, or you simplify at the end, again, is entirely up to you, whatever you feel more comfortable. Now with algebraic fractions, the concept is the same. However, I do have some top tips for you to do, and I'll try and implement these when we go through some examples, and I'll try and emphasize what they actually mean as well. So my first top tip is that when you have more than one term in the numerator or denominator, use brackets. So what I mean by that is if I had x plus 3 over 4 plus, let's say, 2 over x minus 3, then what I mean by this is if you've got two terms which we've got in this first numerator, put brackets around them. It just makes it a lot easier for you to read, less likely to make a mistake, and less likely to mess up when it comes to using negatives and positives, etc. The next tip is be extra careful, and again, nice little segue there, is be extra careful with subtractions and minuses. So just be mindful of this, and obviously check your answers if you've got access to the answers, but just be mindful, particularly when you're subtracting two algebraic fractions, just be mindful that obviously then it's going to reverse everything in that second fraction in the numerator. The next one is if you have a bracket in the denominator, don't expand it. Now this kind of follows in when we're looking at simplifying algebraic fractions with factorizing, but the general rule is expand out any brackets you've got on the top, but try and leave the bottom unfactorized, so keep the brackets in the bottom. And the next tip is you don't always have to do something to both fractions, so maybe just one to get the denominator same. So an example of that would be something like if I had let's say 2 and x plus let's go for x plus 2, and that be a 3, then here I don't need to multiply both the denominators together to get x squared plus 2, x plus 2. I can just simply multiply this second fraction, let me get a nicer pen, this fraction by x plus 2 and x plus 2. So giving me a common denominator of x plus 2, x and then x plus 2. So here it will be 2x plus 2 over x plus 2. And there you can see that my denominators are now the same. So I needed to do 1. And the last tip is that you can check your answers by substituting a value of x into the question and your answer. And if it's correct, then this should give you the same answer. So what I mean by that is if I had x plus 3 over 2 and I had x minus 1 over 3 and I get an answer of 2x plus 4 over 6, let's say, then if I just pick any number, so let's go for x equals 0, I substitute it into this. Is my final answer, and if they give me the same answer, then I know then I'm absolutely fine. So that's just one way of checking. If you've got that extra time, it's not always essential. You kind of hope that if you've done it correctly, your answer will be correct. So now let's have a look at some actual past exam questions. So looking at this first one, it says simplify fully. So here I'm multiplying. So all I want to do is just multiply the two numerators together and multiply the two denominators together. So this is going to be then a cubed, b squared and c. And at the bottom, I'm going to end up with a, b, 5, c, d. Now from this, what I then want to do is then simplify this, so cancelling the like terms. So I've got 3 a's at the top and 1 at the bottom, so that cancels and that changes to a 2. I've got 2 b's at the top, so they cancel, and I'm then left with 3 b's at the bottom, and the c cancels out. So what am I left with at the top? Well, I'm left with a squared over, and what I'm left at the bottom is just b and d. Well, actually it's b cubed, and there is my final answer. So it's a squared over b cubed d. Then moving on to question 2, it says show that for when x is not equal to 0. Now the reason why they write this is because obviously we've got x in the denominator and you can't divide by 0. So it's just emphasizing that x can't equal 0. And what we want to do is we want to rewrite and combine these two fractions into one single fraction. So again here we think about what's our common denominator going to be. Well, our common denominator is, if I just write common denominator, it's going to be 6x. So I'm going to multiply this first fraction by 2 and I'll multiply this second fraction by 3. And again, what I want to do is just put brackets around those things there. Now, not necessarily need it for the 2x, but definitely for the x plus 4. So here, multiplying that first fraction by 2, I end up with 2 and then x plus 4 over 6x equals, and multiplying the second one, actually it's not equals, it's minus, and then minus, and then multiplying that second fraction by 3, so that's going to be 15 over 6x. And then once the denominator is the same, I can join the two numerators together, so I've got 2x plus 4 minus 15 all over 6x. So from this, what I then want to do is simplify and expand and simplify, so I get 2x plus 8 minus 15 all over 6x, which gives me 2x minus, and it's going to be 7 over 6x, and there is my final answer. And again, just to double check, as you can see, we've got it in that form. Now, just be mindful that here, again, a is going to be equal to, b is actually, although it's a plus in this, for us it's minus 7, and c is 6. And again, if it did ask for a, b, c values, then that's what I'd give, but I'm happy to leave it in its fraction form. Then moving on to question 3, again, very similar. So here we want to combine the two fractions we're adding, so we want to get a common denominator. So here our common denominator is going to be 6. So if I multiply this by 2 over 2 and I multiply this fraction by 3 over 3, what we get then is it's going to be 2x plus 1 over 6 plus, and then it's 3 lots of 5x minus 2 over 6. So then combining the two numerators together, and again you could expand at this stage, so I've got 4x plus 2 plus 15x minus 6 all over 6, and then if we simplify all of that we get 19x minus 4 over 6, which is what they wanted me to show. Then moving on to question 4, it says solve, and then here we've got this. So here, our common denominator, so common denom, is going to be x minus 2x plus 3. So from this, what we've then got, now this one's a little bit cheeky because we've got a solving one, not simplifying, but the same concept applies. So here what we've got is we're going to multiply this first fraction by x plus 3, and we're going to multiply this second fraction by x minus 2 over x minus 2. So from here what we've got is we've got 6x plus 3 over x minus 2 x plus 3 minus, and then we've got 2 lots of x minus 2 over x minus 2 x plus 3, and that all equals 1. Now again, from here what we can then do is add the numerator, or take away the numerator. So I've got 6x plus 3 minus 2x minus 2 all over x minus 2 x plus 3 equals 1. Then expanding the top and taking all of this over to the other side, I end up with 6x plus 18 minus 2x plus 4 equals, and I've got x minus 2 x plus 3. Then if I just scroll down a little bit more, so you've got a bit more room. So simplifying the left hand side, I've got 4x plus 22 equals x squared plus x, oh, what on earth has gone on there, plus x minus 6. And then from this, what I then want to do is take this over to the other side. So from this, what I've then got is x squared minus 3x, and then it's going to be minus 28 equals 0. So I've got x minus 7 x plus 4. I can just solve it like a quadratic, and so the values of x are x equals 7 or minus 4. Then moving on to question 5, again we've got another simplified question, even though it looks like solving. So here what we want to do is get a common denominator. So our common denominator in this case is going to be x minus 3 x minus 1. So we need to multiply this first fraction by x minus 1 over x minus 1, and I'm going to multiply this second fraction by x minus 3 over x minus 3. So if I do that, I end up with 2x minus 1 over x minus 3 x minus 1 plus, and then 1 times x minus 3 over x minus 1 x minus 3, and that all equals 1. So again, what you want to then do is, now our denominators are the same, we join the two numerators together. So I've got 2x minus 2, and again that mistake is very easily done, so it's a good job I spotted that, plus x minus 3 all over x minus 3 x minus 1, and that equals 1. Then if I neaten up the top, I end up with 3x minus 5, and I take these double brackets over to the other side, so I end up with x minus 3 x minus 1. And then expanding these brackets, I end up with x squared, not x cubed, x squared minus 4x plus 3, and I've got 3x minus 5 on this side. Then if I take all of this over to this side, I end up with x squared minus 7x, and it's going to be plus 8 equals 0, and that's what they wanted me to show. Then moving on to question 6, again we've got a dividing. So again, what do we do here? Well, we flip the second fraction and turn to a multiply. So I got 8c to the 7 over 15d to the 6, and I've got 5d3 over 6c squared, and turns to a times. So then combining the two fractions, I end up with 8 times 5, which is 40, c7 d3 over 15 times 6, which gives me 3090 c squared d6. So if I simplify the 40 and the 90, that becomes 4 and 9. and I lose 2 c's from the bottom, so I've just got 5 left at the top, and I lose all 3 c's at the bottom, top rather, and so I've only got 3 left at the bottom. So all in all, what have I got left? Well, I've got 4c to the power of 5 over 9d cubed. Then moving on to question B, it says to write as a single fraction. So again, that there is a plus. So then here my common denominator is going to be m plus 1, m minus 4. So the first fraction, and multiply that by m minus 4 over m plus 1, m minus 4, plus 6 lots of m plus 1 over m minus 4, m plus 1, and then combining the two numerators together, so I've got 5 and then m minus 20 plus 6m plus 6 all over m minus 1, m plus 1 rather, and m minus 4. And then neatening the top, I end up with 11m minus 14 over, and then it's going to be m plus 1, m minus 4, and there is my final answer. Then for question 7, I've got to just then write this as a single same. So here, I just put brackets around this. So here, my common denominator is going to be x minus 2. So here, what I've got is x minus 2. So that first fraction, I've multiplied that by x minus 2. And for the second one, I'm multiplying that by, well, actually, I've just multiplied that by x. Let me just correct that. And for the second one, I'm multiplying that by x minus 2. So that's x minus 2. Then combining the numerators, I end up with 4x minus 3x. And it's going to be plus 6, because the minus 3 times minus 2 is plus 6, over x minus 2. And then simplifying that, I get x plus 6 over x minus 2. And there is my final answer. Then moving on to question 8. Again, this looks like a complete utter mess, but what we want to show is that this, when we write as a single fraction, can be shown as this. So looking at this, my common denominator is going to be 3n minus 1. So I multiply this first fraction by n minus 1. And I'm going to multiply this second fraction by 3n. So what do I end up with? Well, I'm going to end up with 3n plus 5, n minus 1, over 3n, n minus 1, minus, and then I've got 3n, n, over 3n, n minus 1. Then simplifying the first numerator, I'm going to end up with 3n squared, and then I've got minus 3n plus 5n, which is 2n, minus 5 minus 3n squared, and that's all over 3n n minus 1. Now from this, my 3n cancels out, so all I'm left with is, oh, not 3, let's write that as 2n minus 5 over 3n n minus 1, which again is what they wanted me to show. Now, if you are wanting to have a go at these questions after watching this video again, I'll include a copy of them in the description below for you to download and have an attempt at.